Good evening. Today I would like to explain my conference conference paper title is Assessing the Role of Machine Learning Models in Groundwater Contaminant Monitoring and Management. So, welcome. Myself, Dr. Asadi, and my colleagues are Dr. Alvin Lal and Professor Laureate Ravi Naidu. I have done my PhD in artificial intelligence, and currently I am working on various environmental case studies like groundwater, soil properties, heavy metals, PFAS, etc. And these are my contents of topic: introduction, objective, methodology, results, discussion, future directions, conclusion, references. Coming to introduction, we have collected nearly 10 case studies of different countries in the globe. Groundwater refers to the subsurface water that can become contaminated and requires advanced monitoring and management techniques to environmental to ensure environmental and public health safety. Groundwater contamination poses significant environmental and public health challenges. So, if you take groundwater, there are various purpose we are using, and drinking water, sea water, wastewater, and surface water. So various purposes we are using, and this groundwater contamination having challenges. We are overcoming those challenges in proposed system, and monitoring and management involves using machine learning models to detect and predict groundwater contaminants, enhancing decision making for effective environmental protection. ML and DL techniques enhance predictive accuracy, improve data processing times, provide better decision making capabilities, and offer more robust modeling for contaminant transport, pollution source identification, and monitoring network optimization. So we have collected 10 case studies from different countries: India, China, USA, UK, and Bangladesh and Greece. So uh, across the globe we have collected various case studies like contaminated site remediation, groundwater transport modeling in China, groundwater contaminant transport modeling, groundwater contaminant prediction in the USA, groundwater pollution surface identification in UK, groundwater quality modeling, water quality evaluation studies in China, drinking water contamination studies in USA, groundwater quality assessment in Bangladesh, groundwater pollution source identification in Greece. So these are the case studies we have identified, and what type of methods they have applied, and what are the results and the find outs of each case study. Elaboratively we have done the research review. So from that, machine learning techniques in groundwater management, conventional methods for managing groundwater contaminants have limitations regarding accuracy, efficiency, and scalability. Machine learning models provide enhanced decision making capabilities, improved accuracy, and faster processing times. The objective of our research aims to assess the effectiveness of various machine learning models in groundwater contaminant monitoring and management. Then methodology, machine learning models methods addresses contamination issues by analyzing case studies and data and performing comparative analysis to manage groundwater pollutants. Then a discussion of results. Out of 10 case studies, Machine learning methods such as deep learning emulators, artificial neural networks, and optimized models enhance groundwater monitoring accuracy and efficiency. So, out of 10 case studies, so the the best case study related to our topic, they have used deep neural networks effectively modeled groundwater contaminant transport, greatly improving prediction accuracy and efficiency compared to traditional models. Mazumdar and his team, they have developed a case study, an optimized ML model using XGBoost enhances prediction accuracy and reliability for groundwater contamination, emphasizing the importance of parameter optimization. Then finally, conclusion. So, machine learning models outperform traditional methods in managing groundwater pollutants, especially in simulating contaminant movement and optimizing monitoring networks. The research recommends improving machine learning algorithms using real time data and broadening their use in various environments for enhanced groundwater management. So, thank you for these are the 10 references I have used, and thank you for giving me this opportunity. And if you have any queries, you can ask.